Machines learn three things: patterns, patterns, and patterns. And we are going to break down how machines learn these patterns, who teaches them, and can things go wrong?
Hello, everyone, and welcome back to this week's Info Rush. I am Dasha,
I am Rudrakshi.
and welcome to our episode 2: AI Magic or Logic.
So, Disha, just the other day we were talking about starting this podcast, and I think there were a lot of things to do, like um, explore the topics and do a lot of research, how to record, like how to even use all the cameras and settings, and a lot of it was quite overwhelming. So we did do Google search then, and of course it was very tiring. So we turned to our famous AI tools, ChatGPT, Gemini, Perplexity, just to name a few. There were a lot more we explored, and that's when I paused and thought, how did these systems get this good, like good enough to surprise us? How do they know almost everything? And what's actually happening behind the scenes? It was quite surprising.
That's true, and it's not just you. This thought might have crossed a lot of people, and isn't that why we are here?
Hmm.
So, first things first, when we talk about AI, we talk about machine learning, deep learning, and data science.
I think for any non-tech or even a tech person for that matter of fact, all these terms are too overwhelming. And even when I was studying for like my placements or even during the whole course duration, I used to get like not just me. I think a lot of people got confused into all these terms. We thought it was the same thing. Can you just break it down for us and like simplify?
Sure, so let me explain. Now, think about an exam. Artificial intelligence is simply the goal, it's the result on the report card. It's the smart student who can see, listen, and solve problems just like a human. Now, how is that achieved? Historically, the approach was the rule book method. This is traditional coding. Imagine a student is allowed to bring a cheat sheet into the exam. The sheet contains strict rules. If the question asks about apples, write fruit. If the question asks about cars, write engine. This works great until a trick question appears. What if the question asks about a Apple computer or a toy car? The rule book fails because no specific rule was written for those exceptions. This is where machine learning changes the game. Instead of providing a rule book, the system is fed 10,000 past exam papers. The instruction changes. It's no longer about following rules. It is, here are the questions and here are the correct answers. Figure out the pattern. The student, that is the machine, starts solving them. At first, it guesses, but slowly it notices patterns that weren't explicitly taught. It learns that apples usually mean fruit, unless the word MacBook is nearby. It isn't following a pre written rule, it is learning the logic by looking at the data. But what if the exam is too complex for a study guide? What if the questions are messy, like recognizing a face or understanding a joke? You need to go deeper. You need to stop relying on the teacher's highlights and build your own intuition. This is what is deep learning. It's a subset of machine learning, but it mimics the human brain using something called as neural networks. And you know what? We have an AI engineer with us, so I would really like for her to take over.
So concept of neural networks, it comes from something like a human brain itself. So think of it like layers of understanding. Layer 1 sees a line, layer 2 sees a shape, layer 3 sees the face. The student isn't just following rules anymore, they are getting a PhD. They are finding connections that no human ever taught them to see. Now, within deep learning, there is a specialist. And I guess everyone knows it is the large language model, LLM. Think of an LLM as a student who has read the entire library, books, articles, tweets, code, but they didn't just read the words. They studied the probability of them. They know that if I say once upon a dash dash, the next word is 99% likely to be time.
Time.
They understand context, tone, and grammar because they've seen billions of sentences flow together and how they stitch together in general.
Right. And I think this is where then generative AI
Correct.
comes in. So, generative AI is what I would say is the action. It is what happens when you hand that well read student a blank sheet of paper, the topper who will take like a
Right.
number of supplements, I would say. So instead of just answering A, B, or C, the student starts creating. It remixes everything it learned in the library to create something brand new, like writing a new essay, painting a new image, or composing a new song. It's not magic, it's just predicting the next piece of the puzzle based on everything it has ever seen. But wait, there is one piece people often forget. None of this works if the textbooks are torn or the study material is full of errors. This is where data science steps in. First, it is about preparation. It involves organizing the library and cleaning the messy data so the students has clear material to study. But equally important is evaluation. You don't just send the student to the final exam immediately until and unless it's a topper
But
and
yeah,
or
even
a
that topic goes through a
prodigy.
lot of mock tests and
Yes,
stuff,
no,
right?
that's true, that's true. So you give them a mock test and grade the paper, as you said. So, did the system score 90% or did it completely misunderstand a specific topic? Data science involves analyzing that report card using specific metrics to measure accuracy and determine if the model is actually ready for the real world. Because if a genius student is fed bad textbooks or if their test scores are never evaluated, they will fail the exam. So, data science ensures that the AI is learning the right things and measuring how well it learned them.
It makes sense now. Like when I also work, we kind of underestimate how important the data quality is and how important the evaluation is. So I'm glad that you put it up. Now that this analogy simplifies a lot of these intimidating words, now coming to the next main big question: how does a machine actually learn all of this? I mean, these are pretty complex things. So
Right. So, if we stay with the example, there are three things no student can learn without: books, a brain, and time. Machines aren't very different. First, books. For a student, that's textbooks, notes, and question papers. For a machine, that's called training data. Training data is just examples: photos, text, videos, voices, whatever the machine is supposed to learn from. So, if AI needs to recognize faces, it learns from lots of face images. If it needs to understand a language, it learns from huge amounts of text. Second comes the brain. For humans, it's our brain that we have. For machines, it's called a model. A model isn't magical. At its core, it's math and statistics. It uses equations to measure things like what's similar, what's different, what matters more. Now, you might be thinking, how can a machine remember what it has learned? Just like our memories, models store weights. That understanding, built using math, statistics, and weights, is what the model represents. You can think of it like this: two students can read the same book, but the one who understands the logic behind the answers performs better and remembers things better, and that student then scores higher.
So I think better accuracy. Yeah,
Yes, exactly. This is exactly why you often get separate answers from
right.
separate models. For these models, there is no intuitive thinking, just math repeated again and again. And finally, the third thing is time and effort. For students, it's hours of studying and revision. For machines, it's called compute. But who is the teacher? Well, on the surface, it's the engineers and researchers, but not just them. It's a whole ecosystem of people involved at every step, from data collection and curation to evaluation, feedback, and refinement, all collectively shaping the final outcome. That's how machines learn. But just like exams, if the material is bad or the logic is flawed, or the practice is rushed, machines can learn the wrong things too. That is why we often say, oh, AI, it just gave me, it threw a wrong answer. But there's nothing to be surprised about, because, as I said, if the certain things which are uh, being fed to it which are not right, so there might be outcomes that might also be flawed.
So let's quickly zoom out. AI isn't magic, it's complex math, statistics, and data. Machines learn the same way we do from examples using logic, and with enough practice, what we call training data is what the machine studies from. What we call a model is the math and statistic doing the learning or the computations, and what we call compute is the time and effort spent practicing. Get the balance right, and AI can do incredible things. Get it wrong, and it can confidently mess things up. That's the real logic behind the magic.
Yes, very aptly put. So, if AI is just patterns, math, and practice, why does it feel so big today? Because this overnight success took decades and it wasn't a smooth ride. There were bold promises, hard limits, and can you believe that there was even a period where people gave up on AI entirely? Stay tuned as we follow the trail of AI from an underdog experiment to a world shaping force. And that's today's info rush. Stay curious, stay skeptical, and log out smarter.
And don't forget to follow us on any platform that you get your podcast from.